Okay, let's jump in. In this tech world where everything seems shiny and new, there's this older language, C++, and that's still incredibly important.
It really is. It's kind of like the foundation under a lot of the flashy stuff we see.
Exactly. Like a master craftsman's toolkit. Maybe not always visible, but totally essential for the really heavy-duty work.
Hmm.
So today on the deep dive, we're going to, dive into C++N. You've got some great material here to help us unpack its history, what it's really for, and why it's stuck around so effectively.
Yeah, the goal is pretty straightforward, right? Give you, the listener, a solid handle on what C++ actually is.
Right. Why it still matters so much, and maybe even, who should think about learning it, or perhaps who shouldn't.
Consider it your shortcut to getting up to speed on this cornerstone of programming.
So C++N, it's got this incredible staying power. Where did it even come from? We're talking the 80s, right?
Yeah, way back. To really get why it's still here, you have to look at what problems it was trying to fix back then.
Okay, so picture the 80s. C was king for operating systems, low-level stuff, super fast, super efficient.
Absolutely. But C had limitations, especially as programs got bigger and, well, messier.
Messier how? Like just harder to manage.
Yeah, organizing big projects was tough. And crucially, it wasn't really built for object-oriented programming. This idea of bundling data and the functions that work on it together into neat little packages, or objects.
Which makes code easier to reuse and manage, right? Less chance of breaking something over here when you change something over there.
Exactly. It was becoming a real bottleneck for complex software development. And that's where Bjarne Stroustrup comes in.
The creator.
The creator, yes. His big idea was basically, let's take C, keep all its power and speed, but add these object-oriented capabilities on top.
So you have the best of both worlds, sort of. The low-level control and better organization.
That was the goal. Build more structured, more robust software without sacrificing that C performance.
And the name itself, C++N. I always thought that was quite clever.
It really is. The F++ is literally the increment operator in C.
Meaning add one or step up.
Precisely. It perfectly signaled this is C, but evolved. The next step, not something totally alien.
Okay, so it solved a problem back then. But
Yeah.
fast forward to today. Why is this, incremented language still so vital? We have so many newer languages now.
It boils down to one main thing, really. Control. Unmatched control over the computer's hardware, especially memory.
Ah, memory management. That's the big one with C++, isn't it?
It is. In areas where performance is absolutely non-negotiable, that fine-grained control isn't just nice to have, it's essential.
So where do we actually see this in action, like real-world examples?
Oh, all over the place. Think about huge, complex video games. Engines like the Unreal Engine.
C++C.
Heavily C++ clay.
Yeah.
Then you've got financial systems, high-frequency trading platforms, and big banks.
Where microseconds matter.
Exactly. They need to crunch massive amounts of data incredibly fast. C++ is often the engine behind that.
Wow. Okay, what else?
Embedded systems. Think about the software running inside devices, like the control systems in a Tesla car, or avionics in aircraft.
Seriously, mission-critical stuff.
Absolutely. Even things like Adobe Photoshop, where you need that responsiveness, that speed for manipulating huge images.
Right, you can't have lag when you're doing complex edits.
No way. And even space research dealing with really demanding calculations. C++ pops up there too.
So the common thread is maximum performance
Yeah.
and talking directly to the hardware.
Pretty much. C++ lets developers manage memory directly, like literally decide when memory gets allocated, how it's used, when it gets freed up.
Which is different from a lot of modern languages.
Very different. Languages like Python or Java, they have automatic garbage collection. They handle memory management mostly behind the scenes. C++ puts you, the developer, in complete charge.
Which sounds powerful.
It is incredibly powerful. It's how you squeeze out every last drop of performance.
But I sense a but coming.
Well, yeah. With great power comes great responsibility, as they say. If you mess up memory management in C++ and it's easier to do than you might think, you can cause crashes, weird bugs, even security holes.
Stuff that's really hard to track down later.
Exactly. It demands a lot of care and attention to detail.
Which leads us, I guess, to the infamous learning curve.
Yes. It's definitely known for being tougher to learn than, say, Python or JavaScript.
Why is that specifically? Is it just the memory stuff?
That's a big part of it, but it's also just lower level. Modern languages often abstract away a lot of the machine's complexity. They kind of hold your hand.
Okay, so give me an analogy.
It's like Learning to drive an automatic car versus learning a manual. The automatic does the gear shifting for you.
Right.
With a manual, you have to understand the clutch, the gears, how they interact. C++ is like the manual transmission. It expects you to understand the underlying mechanics.
You got to know how the engine works, not just how to turn the key.
Precisely. You're closer to the metal.
Right.
But there's an upside to that struggle.
Oh, yeah. What's that?
Because C++ forces you to understand those fundamentals, how memory works, how programs actually interact with the hardware, it gives you a much deeper understanding of computing itself.
So learning C++ can actually make you a better programmer overall, even if you end up using other languages later.
Many people find that, yes.
Right.
That foundational knowledge is really valuable.
Okay, so given all that, the power, the responsibility, the difficulty, when should someone actually choose C++ for a project?
Well, if performance is absolutely critical, like #1 priority.
Got it.
If you need to manage hardware directly, if you're building something like a graphics engine, a game engine.
Intense computations.
Yeah, heavy-duty calculations, key systems programming, game dev, robotics, areas where that efficiency and low-level control are just paramount.
Makes sense. So conversely, when is it not the right tool?
Probably if you're building like a standard web application or maybe a simple script.
Like a basic company website or something?
Yeah. For that kind of thing, languages like Python or JavaScript are often, frankly, much faster to develop in and more than capable enough performance-wise.
You don't need a Formula One car to go to the grocery store.
Exactly that.
Yeah.
Use the right tool for the job.
Now, one thing people sometimes say is that C++ is, well, old, maybe outdated.
That's a common misconception, but it's really not accurate. C++ hasn't just been sitting still since the 80s.
It's evolved.
Massively. There have been major updates. You hear people talk about C++ 11, C++ 17, C++ 20.
What did those updates bring?
Oh, lots of modern features. Things like smart pointers, which help manage memory more safely, reducing the risk of those leaks we talked about.
So making the tricky parts a bit easier.
Trying to, yes. Also, things like Lambda functions, which make code more concise. Better support for concurrency, running multiple things at once on modern processors.
So it's definitely kept up with the times.
Absolutely. It's adopted modern programming practices while still retaining that core performance focus. It's a living language.
So if we were to sort of boil it all down, C++ isn't just code. It's almost like a philosophy, a way of getting closer to the machine.
That's a great way to put it, actually. It forces a deeper understanding, a more direct interaction with the hardware.
It's demanding, requires discipline.
Definitely. It's challenging to master, but for those who need that absolute control, particularly in those performance-hungry fields, the knowledge and capability you gain are pretty invaluable.
Okay, so wrapping up this deep dive, it seems pretty clear. C++ might be older, it might have that steep learning curve, but it's still incredibly relevant.
Essential even in specific domains. Anywhere that speed and direct hardware control are the name of the game.
Which leaves us with a final thought for you, the listener, to mull over.
Yeah, think about this. C++ is fundamental to so many technologies we rely on daily, right? From our games to our financial systems, maybe even parts of our cars.
Right.
So, as this old language continues to evolve, getting new features, becoming maybe a bit safer to use, what are the implications of that? What new possibilities or perhaps unforeseen challenges might arise from the ongoing modernization of such a foundational piece of technology?
That is interesting, and maybe now, knowing a bit more about the kind of fine-grained control C++ offers, maybe you'll look at the software you use differently. Think about how efficient or maybe inefficient it might be under the hood.
Definitely something to ponder. Where is C++ hiding in your digital life?